Hello everyone, welcome back to CoffeeJUG, and today we would like to host the perfect speaker, Alex, today with us. And let me go to the next slide. Yeah, first of all, welcome. And first of all, we want to thank you to Ukrainian Armed Forces who fights every day to liberate Ukraine from Russian troops. Thank you for this. And for our community, we already did more than 50 events with more than 500 participants in the CoffeeJUG. And also want to thank you to our organizers team, Igor, Uliana, Olesa, and Oleg, and to our community partner, JetBrains. And join us in our social medias in Facebook, Twitter, or X, and in Telegram. That's it. And I give the stage to Alex. Thank you.
Hello, everyone. Can you see my screen? Do you guys see my screen? Can I get the confirmation?
Not yet, Igor. Could you share Alex's screen?
Well, while my screen is being shared, maybe I could introduce myself. So I work for Red Hat. I'm one of the engineers working on Quarkus. Great, I can see my screen now. And so, yeah, I've been working on Quarkus for the last, well, since 2018, so almost 6 years now. So I was there at the beginning. And so, yes, today I'm going to give you a presentation on what Quarkus is about. So it's a bit of a spontaneous presentation, but yeah, I hope you will get a good idea of what this is and how Quarkus works and what it actually solves. So let's start by, let me share my presentation this way. So first of all, when we discuss when you discuss with the customer, for example, your next project, right? And what you eventually get paid for is the outcome, right? So this is what we get paid for, and this is what customer is primarily interested in. And of course, we want to make the result, the product that we deliver, perform well, right? So it has to. The performance is a one of the key characteristics. But the customer might not necessarily be interested in how you produce this product, but us as developers, job is a big part of our life, and so for us the process matters as well. So it would be good to be able to actually enjoy the development process. And this is the two key points that Quarkus was designed to satisfy, right? So we do care about the performance. So because the when you develop a product and when you deliver the product, there is a lot of code that is not written by you, because you have lots of dependencies, and a lot of dependencies come from the framework itself. So the quality of the framework matters. So the framework has to be really designed for performance. On the other hand, um, the development process has to be at least not painful, right? It has to you have to be able to enjoy it, and so it has to be adapted to modern practices, and yeah, just be inspiring and make you a creative person as an engineer. And so these are two key points that Quarkus wants to deliver on, and this is what it was designed for. So Quarkus was the original prototype of Quarkus was created in 2018, And at that time, it was kind of a difficult moment for Java community, because at that point, a lot of application development and deployment primarily started to move to containers and cloud, right? And Java was not designed for that. So, engineers like me, or me specifically, who worked on an application server. So I come from JBoss. I worked for JBoss for 15 years. And so for us, we developed software for, dedicated. We would assume that it would be running on dedicated server, and memory was not an issue. It would be a long-running process. You would launch it, and it would run for weeks, months, maybe years, right? So what if it takes a couple of minutes to start? It doesn't matter really. But with Kubernetes and container-based, deployments, it the, the the technologies shifted. Um, Suddenly, the boot time and memory footprint became highly critical. And Java started to lose its competitive edge to other technologies. Even Node.js started to perform better in that environment. And so at that point, we started to think, so what about Java, right? And so Quarkus was an attempt to, from our end at least, it was an attempt to make Java competitive in containers with other technologies. So that was the initial inspiration for Quarkus. So how could this possibly be done? Well, when it comes to Java in general, what do we mean by this? So there is a JVM. The JVM itself is a machinery, right? And then there are applications and frameworks. So I'm talking primarily about frameworks here. So for example, Quarkus and other development frameworks maybe, right? So I'm not going to go into details of JVM, and those teams working on JVM, they realized it as well, and they are doing their best to adapt JVMs for these new use cases. Well, not new anymore, but so what could we do on our level to improve the situation? So first of all, one thing we realized immediately was that typically a Java application contains a lot of dependencies, and that means a lot of classes. So classes is actually important. So class loading is it's an expensive operation to load a class, validate bytecode, and it takes time and it takes space. So that's one of the things. And there are other things that we will look into detail. But so Quarkus, the idea behind Quarkus was to minimize the runtime, the bytecode that actually represents the runtime, to minimize it as much as possible, right? So we want to eliminate all the dependencies that are not necessary at runtime. And so what could that possibly be? So if we take a typical, like, let's call it traditional Java framework, the way they work is, so you build your application with Maven or Gradle, you produce these jars, and then when you launch an application, there is something like this is happening. So when you launch your application, there is some kind of bootstrap mechanism that is kind of waking up and starts to look around what is available. So it will probably be looking for some configuration file to read, right? Maybe it's an XML or something. So it will read the file and then say, okay, so I need to instantiate this class and set these values. And then, there is every framework is now based on annotations. So there will be annotation scanning. So, and actually every library will probably do the same sequence, but on its own, right? So there is Hibernate, there is something else. All these libraries will be scanning the whole class path to recognize their annotations. And then they create the meta model of what was configured and validate them. And at the last phase, they will actually initialize all the services, and the application will be ready to serve requests, right? The important part here is that This whole process from reading configuration to the ready state, it takes quite a lot of time, and it's quite well, intense process in terms of what has to be done. And it will be repeated every time. So if we imagine that we deploy to Kubernetes, our application, right? And the system starts to scale in, scale out. The application, when a new instance of the application is created, this application will go through exactly the same phase because the configuration doesn't change, right? So all this sequence will be repeated as many times as we start a new instance of the application. And so that fact gave us an idea. So how about in Quarkus, we try and optimize um, an application boot to a specific configuration. So basically, what we started to realize is that most of the configuration of an application is static. Right? It doesn't change. So if you create a new instance, the configuration, most of it doesn't change, right? Or it doesn't change at all. So at build time, we have access to configuration files. We definitely have access to all the annotations and all the other things, right? Some resources and things like this. So the idea was, how about if we analyze the configuration annotations and all the other stuff at build time and generate the bytecode that will initialize the application directly. So in Quarkus, we use some clever tricks. At Quarkus application build time, we figure out what a library has to do given a specific configuration and annotations to initialize its services, let's call them that way. And then we actually recode this bytecode so that when you actually boot the application, we just replay the bytecode instead of reading the configurations, scanning for annotations, and doing all these things. And by doing that, so if we just move all this most of the initialization, right, to the build time, then what we achieve is, well, first of all, we definitely save time, right? So we just don't perform these steps when we boot the application. But the other thing that we avoid is classes and libraries that are needed to perform all these steps. So for example, if my configuration file is an XML file, right, and I need to parse it, I need an XML parsing library, right? But if at runtime I actually don't need this parsing library, then we could eliminate it by processing this XML file at build time. And so the whole library will be removed from runtime. So that's the trick. And well, once we did this, this is how the picture has changed. So with Quarkus approach, we actually started to approach more the Golang quality in terms of, actually both in the boot time and even memory footprint. Right, so it's definitely better than Node.js at least, which is a good thing. And here's a little comparison of Quarkus to kind of traditional stack. This picture is from our website, and you can actually see that the results are pretty impressive, right? So with the same JDK, with the same kind of application, you can save a lot of space and also time. Yeah, it's kind of self-explanatory, so I'll just skip it. And so we kind of end up with this build time optimization framework called Quarkus, and we can develop actually all sorts of applications. So Quarkus is not specialized for development of microservices or compiling applications to native. You can actually develop anything you want. It's just a build time optimization framework. Okay, so you could see various examples here. So microservices, event-driven architecture, Kubernetes operators, You can develop CLI applications and even GitHub applications. One thing it doesn't show here is, I should add it here. So for example, you could develop, we have a good AI integration that probably deserves its own presentation at some point in the future. Yeah, so it basically, you can develop anything with Quarkus. And then, yes, the other point is there is a Quarkus enabled a different developer experience, a more enhanced one. And this is what I want to show now. So if you want to, so an easy way to start an application would be to go to this website called quarkus.io. And here you can select, there are some pre-selects now. So you can, here you go, you can develop an AI-infused service, for example. But yeah, you can select a type of application you want, and there are some pre-selected extensions, but you can also search for, you can get a complete catalog of all the extensions Quarkus has, and it will be, I think it will be more than 700 or something. Don't remember exactly the complete list. So as an example, I was thinking, well, given my presentation is not, is kind of an overview of Quarkus, and if you don't know much about Quarkus, you probably know a lot about Spring, right? So I was thinking, instead of showing you the API that Quarkus promotes as the first choice, I was thinking maybe I could show you how you can develop Spring applications using Quarkus, basically using Spring API. So what I mean by this, so I will definitely not use Spring as a library, as an implementation. What Quarkus offers is a Spring API, a kind of facade that is kind of remapped to Quarkus, well, API that Quarkus would normally use, right? But for you on the outside, it will look like I'm developing a Spring application. So for that, if you want to replicate what I am doing, so you could go to this website and, for example, write Spring Web, and then click on this extension, and then generate your application, and you can download the zip, and that will be a project that you could start with. I will do it slightly differently. So there is also a Quarkus CLI here. You can install it with SDK min, for example, SDK install Quarkus, and this is what I will be using instead. So except I have an alias, I call it QS, but it's a Quarkus CLI. So here I say create application. This is what I want. This is how I named it. This is the name of the application. I want to add Spring Web as a dependency. So this is what I'm going to do. So I created my application. Now I will open it in, this is not it, don't worry. I'll open the project that I just created. Here we go. There is a README, very small. We don't care about this. I'll open the terminal here. Okay, so this application at this point contains a single controller. And as you can see, I hope you can see it well, it's just Spring API, right? You can see org, Spring Framework, and all this stuff. So it's a Spring controller. Once I have this kind of project, I can launch it in Quarkus dev mode. Here's how I do it. So I would say Maven Quarkus dev, and that's it. And so I'm now the application has been compiled, and the Quarkus process, build process has been launched, and it launched the application in dev mode, right? It's not production. So it took a bit longer. As you can see, it took over a second. So now my application is running, so I can actually see the results. So this terminal is actually interactive. So if I click on W here, it opens a web page. And this is the main page of my application, kind of the index page. So there is just very basic information. There are some links to guides, how to develop and set up your environment and so on. So to see the result of my endpoint, I'll go to greeting. And here is the response. So it matches, right? Since my application runs in dev mode, I can apply changes and refresh the page, and I can see the result immediately. So this is what we call live coding or live reload. So in Quarkus in dev mode, I can write code, and then I can go to the page, refresh, and see the result immediately. So what we achieve by that, obviously, we save on the cycle of applying changes, building, launching, and launching the application process and seeing the result, right? So now we kind of avoid it, so which is quite nice, I would say. The other feature that is kind of in the same category of what I just showed is called continuous testing. So in this terminal, I'm not sure whether you can read it well, but it says R to resume testing. So if I press R, it will launch the tests. So when the project was generated, it also included a little test here. And of course, now it fails because I changed the response value, right? So continuous testing is also listening to changes that I apply. And once I apply change and save a file, it will rerun the test and show me the effects of my changes, right, on the test suite. So here's what I'm going to do. CoffeeJUG. Hello, CoffeeJUG. I save the file, and I can see immediately the effects of my changes. So now the test is passing, and I could do it, you know, as much as I want. So if I change it again, change it back, as soon as I save the file, the tests are run. So you may have a question, what if I have 1,000 tests? So this, the Quarkus continuous testing is kind of a smart thing. So it will not run all the tests usually. It will run only the tests that are somehow linked to the changes that I apply, right? And I will show that a little bit later. But it will just figure out if I modify this controller, it will figure out which tests are affected, and it will rerun only the tests that somehow are affected by changes in greeting control. Okay, so actually, when I launch the application and when I start continuous testing, the first run will be a full run, but you also can control the set of tests you want to enable in continuous testing mode. Okay, all right. But the idea again is the same. So I just apply changes and I can see the result immediately without, rebuilding, recompiling, or retesting my application on the command line. Okay. So that was the dev mode, right? We will go back to dev mode in a little bit, but I wanted to show you how you can build the application for production. So, well, that's basically the same thing that you are familiar with. You would say Maven clean package. I'll skip the test just to make it a little bit faster. And that will be it. Okay. So by default, Quarkus uses so-called fast jar packaging, and it's a packaging that is so-called. So if I look at the target directory, I will see the Quarkus app directory. This jar is just a default jar that Maven builds. It's not a runnable jar, just the basically classes contained in this module, but it's not an application. The application is here, and this is a kind of directory layout based distribution, right? So if I look at the Quarkus app directory, you could see the lib directory. There are all the runtime dependencies, and this is the runnable jar that I would run if I wanted to launch my application and so on. If I wanted to build an Uber jar, right? So a single jar that bundles everything, I would do something like I open application properties, Quarkus, package, jar type, and I would say Uber jar. And then if I rebuild my application, that will be the Uber jar. So that will be the jar that I could distribute. So the whole application will be in a single jar, of course. I can launch it, Java jar target. Here we go. All right, so yeah, and yeah, so that's an application. That's basically a Spring application developed with Quarkus, right? Like a very simple one, but still. And also, if I could also easily build a native executable with Quarkus. So if I just add dnative, it launches the build and it will produce a native image. Now let me explain to you how this actually works here. So here, when there is a Quarkus build goal, and the first thing it does, so we compile a JVM executable to a native image using GraalVM, of course. And the first thing the Quarkus does, it is looking for GraalVM distribution in this environment on my computer. And it says that I cannot find native image in GraalVM home. So basically, I don't have it installed and set up. And so it warns about it, but it still proceeds with the build. And what it does is, here it says, I'm pulling a builder image. So it pulls a container image with GraalVM distribution. And it will be called Quarkus Mandrel. So Mandrel is a distribution of GraalVM that Quarkus uses. And so my native executable for this application will be built in a container, right? And what this means is this binary will be native to a Linux container that produced it, right? So if I was on Windows and build the binary in this way, the binary would be a Linux binary. So I wouldn't be able to run it on Windows, right? So if I wanted to produce a binary that is native to Windows, I would have to set up GraalVM, install native image. It actually mentions how to do it. I mean, it's just a hint. We have proper docs, of course. But this is what I would have to do. And then Quarkus would build an image for Windows or Mac OS and so on. All right, so the process is over. And here in the target directory, here's my native image. And it starts, as you can see, in 11 milliseconds. And it still works. All right. All right. So now I want to go back to dev mode and show you a few other features that Quarkus offers. But before I do this, I will add a few other Quarkus extensions. Quarkus extension add, I will add Spring Data JPA and JDBC Postgres. Right. So what I just did was I just added a couple of dependencies to my project. So if I look at my POM file, I could have added them manually, of course, but I just used the CLI. This is what it added, just for information, just Maven dependencies. All right. So now that I have them, I can, again, launch my application in dev mode. And I will write a little entity and show you some more advanced features. Okay. So the application has started. I can also run the continuous testing. Right. Okay, so let me add an entity. Let's call it a fruit. So that will be an entity. I'll add an ID. ID will be an ID. Will be a generated value. Private string name. Private string, let's say color. I'll add a couple of constructors. Constructor and getters and setters for everything. All right. Okay, so And now I will add the repository. So let's say that will be an interface fruit repository. Okay, extends fruit repository fruit long. All right, that's it. Good. And so to be able to display them, I will add a new controller for fruits. Oh, I'll copy this one, paste. Fruit. All right. It shows compilation failed, but this is just probably the way IDE creates files, so we ignore it. I'll say it's fruits. And let's return all the fruits. Okay. Oh, I need to inject the private final fruit repository. Okay, constructor, injection, and return fruit repository find all. All right, that's it. So now if I go back to my web browser and say fruits, I need to spell it correctly, fruits. Okay, I got an empty array, right? So it actually worked, right? So how did it happen? The question is, how did this happen? So my application, so I created an entity that is supposed to be fetched from a database, but I didn't configure any database, right? And here's my properties file. So there is no database configuration. So what happened in this case? Well, this is the development mode. So Quarkus figured out that, well, I have a JDBC driver as a dependency, and it's a Postgres. And I have some entities. So most probably I will need a database to, fetch data from, so to manipulate the data. So Quarkus started a database for me. And this is where the query went, and this is the result. So there is no data basically. So Quarkus created a new database for me and performed these steps, right? Yeah. So this is what is called a dev service. So dev service is a service that is supposed to be an external dependency of an application. But in dev mode, Quarkus, instead of you setting up these services as your development environment, Quarkus can figure it out and bootstrap them for you. So okay, so for now I don't have any data in the database. Here's how I can add it. So I could create a file. I could call it import SQL and write, for example, insert into root ID name color values. Well, let's say one apple, let's say green, then I column. All right, so now if I refresh the page, something didn't pick up. Refreshing the page, here's my apple, okay? So yeah, I could add a few more fruits. Here, let's say 2, 3, peach, banana would be orange and yellow. Okay, refresh, and I got all of them. So as you can see, I just changed the files. They're not necessarily Java files, that they could be resources, configuration files. And all I do, I just refresh the page. And what happens behind the scenes when I do this, Quarkus is checking when Quarkus receives a request, Quarkus application, it checks whether the files have changed on the file system, the sources, the configs, the resources. And if changes happened, it will recompile them. It will stop the application, the one that's running, launch a new one, create a new database, execute the imports. So import the data, and then perform the request that it received, serve the request, and send the response back, right? And it happens, as you can see, pretty fast, right? So as we say, in the blink of an eye. All right, so now let's see how I can write a test for it. So if I copy this file, say paste, fruit controller test, okay. So for now, this is just a copy, right? So as you can see, all two tests are passing, but this one is testing another endpoint. One thing I could do is say fruits, I think. And if I save it, as you can see, it failed, of course, because now this fruits endpoint returns this JSON string, and it's been compared to a string hello CoffeeJUG, and it of course fails. So what this also shows is that this import SQL is used for testing as well, right? And it may look like I'm using the same database for this application that I can see in my web page and in testing, but in fact, this is not the case. So Quarkus, for tests, Quarkus creates another database to isolate the test data from the application that's running in dev mode. It just happened to reuse the same import SQL. And this is not, maybe in my case, for example, this is not what I actually want. So I want to use a different set of data for tests. So what I would do, well, let me show the way I would do it. So if I press D in this terminal, it will open a so-called dev UI. So dev UI is kind of a development dashboard for my application where I could do some operations and see some information that Quarkus extensions provide. So yeah, as you can see, you could see all the bins and interceptors, observers, and databases that you use, some Hibernate stuff, databases, yep, all the stuff. So every extension you add will be added here, and that extension may provide some kind of dev UI gadget, let's say, right? And one of the things that is here is a configuration. It's a little bit big for me. So if I click on configuration, I can see all the configuration properties or options that are available for my application. And this list of properties is not necessarily static. So if I add more Quarkus extensions, they will expose more properties. So more properties will be available. So these are actually the properties that could be relevant in what I'm doing here. What I'm going to do, I'm going to find a property that is relevant for SQL import, and it's called SQL load script. So this is a Hibernate feature. So Quarkus Hibernate ORM SQL load script. If I click on it, it has a little description and some examples. So here it shows an example how you could separate import data between different launch modes. So Quarkus has 3 launch modes for an application: dev mode, test mode, and production. So if I don't add any prefix in my configuration, that will mean that this property will be applied to all modes. In any mode I will launch my application, this property will be set to the value that it appears in the config. But I'm going to do just this. So, and actually there is even a source editor, so I can edit my configuration even here. So if I save it, here's the effect. So basically, if I open it in the IDE, I see the same content. And now I just need to rename this file And so once again, by doing this, I'm importing this SQL only in dev mode. So my tests are not affected. And you can see that immediately in the result. It says that now the response is an empty array here, right? It means that the test database is empty. But if I go back to this application and refresh it, it still has all the fruits. Okay. So let's see how we can add some test data here. Well, one thing I could a little bit make it a little bit better here. So instead of writing fruits here, I could say test HTTP endpoint and say fruit controller class. That way I don't have to do this. So the value of the path will be defined in the fruit controller, and if I decide to change it, I will not have to change my test. So if I save it, it's the same outcome. Well, I could, if I don't want to use specific constants as numbers, I could say HTTP status. Okay. All right. So now, well, what this API is, it's not a Quarkus API, the one that you see here, given, when, get, and so on. This is the library called Rest Assured, and it provides a very convenient API to do all sorts of assertions on the endpoints, on JSONs as well. So in this case, it's an empty string. So what I could do is I could say that the array, I know it's array, so I could say size is 0. Okay, now if I save it, I did my test pass because I don't have any data. Okay, so now let me add some data. Well, first of all, I need to inject the fruit repository, called fruit repository. So it's not, this is a test, it's not an application, but Quarkus allows you to inject beans in the test class itself. Then I will write before each, the little setup. Okay, the first thing I will make sure is that I don't have any data. I want to make sure that before each test, there is no data left in the database. And once I do that, I need to make sure this is done in a transaction. So again, it's not a test method, but I can apply transactional annotation to a setup as well. So all I need to do now is basically fruit repository, save new fruit, say apple, green. Okay. Okay. So as you can see now, my test fails because the size is 1. So I can change it to 1. It's here. And I can, given that it's an array, I could do some more assertions. So I could say that the first item name is apple. Okay, still passing. So I suppose that will be enough for this one. Find all. Okay. And so continuous testing is a feature that actually allows you to do test-driven development. So you can write a test ahead of time and then provide the implementation as well. So if let's suppose I wanted to have a method to create a new fruit. So I could take this one. Say test. Add, and here's how you could do this. You would say body, given body map of class name, let's say page, and the color, let's say orange. Okay, that will be a post. Then, okay, so I will return the entity itself. I will say just the name is pitch. Okay, and if you can see it started to run the tests immediately. Yep. I could also add this thing. Just below it. So now I will have two entities. One of them will be Apple, and the other one will be pitch. Okay. So I'm now testing an endpoint that doesn't exist yet. So I'll just implement this, and this will be very easy to do. Let's change this to find all. Okay. Will be a post mapping. I'll return the fruit. Will be add fruit. All I have to do is save the fruit, and I'll return the same fruit. And it should be transactional. Okay, and I know, so I realized I made a mistake. So if I save this file, you can see that it fails. The test still fails, and the reason it fails is because I didn't set the content. So the content type would be JSON. So now if I save it, the test pass. And so that's basically the idea, right? You can write code and have an immediate response from the framework, how it behaves. So one thing you could also do, which is probably useful, I think. So I'm running this application in dev mode, right? And there is one application that's running here that you can see the web page for, and then there are tests running. So if I'm not actually interested in running dev mode as an application, there is a command for that. So you could that's something to clean up. The command is called Quarkus test. So Quarkus test, Maven Quarkus test, will just launch the continuous testing. So it will run all the tests, and you will have this testing experience, but the application in dev mode will not be running. So it's just a pure continuous testing mode. So if I refresh this page, it doesn't work anymore. Okay. Yeah. So that's basically the idea. So I'm not sure how we are doing on time. We're approaching the end. Let me go back to my slides. I'll say a few more things. So dev services are not limited to databases. So basically, you could see some of them here. This is not an exhaustive list. We have a lot more dev services, but you can see databases. We support some messaging brokers. Kafka could be launched by Quarkus in dev mode, and then, for example, authentication providers such as Keycloak is supported in dev mode, and a lot more. I wouldn't be able to collect them all at this point. And so that was so I was showing you a Spring-based API approach, right? So you could write Spring applications. It's the support for Spring API is limited. It's not everything. If you want to know what's covered, you could just write here Spring, and you could see the extensions that we support, so Spring Boot properties, Cache API, and so on. So you could find them on this code Quarkus.io website. But we cover the basic use cases, and it could be an easy way for you to start with Quarkus if you're interested. You could actually, what you could do is you could develop a similar service in Spring, actual proper Spring, right? And Quarkus, and you can compare the experience, how you develop using each framework, and then you can compare the performance and technical characteristics, for example. And there is also, if you are a Spring developer, there is this book that you could download. It's free. That is basically, well, it's targeted for Spring developers to see how you can develop applications based on your Spring experience using Quarkus, right? And yeah, I think that will be it for today. From me, we can talk. Definitely, we can talk. So let's see if we have any questions. Okay, so I can actually read some chat comments. So does it have service for all extensions? So it's a choice of an extension developer. Not every extension provides a dev service, and for many extensions, it probably wouldn't even make sense. But many do. We're actually working on on tooling to easily display. So, for example, if you go here, how do we? Yeah. So if you go here, we are going to. Well, actually, there is another website. Let me show it to you. Extensions. Quarkus.io. So yeah, you cannot see it, but this is called extensions Quarkus.io, and this is like a global view of all the extensions that in the ecosystem that we are aware of, right? And you can see the number. So just to clarify, we as a Quarkus team, we don't write and maintain all these extensions, right? That's not even possible. But so these extensions are maintained by community members, and there are plenty of them, and some of them could provide dev services, some not. It really depends. So not all of them. And well, you may guess. So if an extension, so typically if it's a service that could be started with it requires a container to start, we would use test containers behind the scene. But it's not limited to that. There is an API that you could run some other launch dev services in other ways if necessary. Okay, it's not limited to databases. What are Quarkus cons? That's a good question. So let me think about it a little bit. Well, okay. So okay, so Quarkus see, Quarkus was designed to build applications to optimize boot time and memory footprint based on specific configuration, right? So typical Java frameworks, you know the advantage of them. They are, yeah, they were designed to be dynamic in a sense that, you know, you launch an application and then this bootstrap, CDI engine would just figure out based on class path what to inject, right? And so one time you launch it and you add this library to the class path, and so it will pick it up a service from it and initialize it, right? And then you would not have to rebuild the application. You would just have to enable a config option or change the class path. And so in a way that is kind of flexible, but it's expensive from the bootstrap perspective. So Quarkus does not allow that. So Quarkus optimizes an application for a specific configuration, right? So you would not be able to say, okay, I built this application with this library that provides this service. Now I don't want to rebuild the application. I just want to completely reconfigure it and like using, for example, environment variables, right? And then launch it, and so the application picks it up. It doesn't work like this. So there are some properties that are runtime configurable. So for example, if you have a database, of course, you will need a database URL, username, and password. And you don't necessarily know this information when you build an application, right? So these kind of properties, you can configure in the environment when you deploy your application. So you would use, yeah, environment variables is probably the best approach to do that. So there are some runtime configurable properties, but most of them, such as JDBC drivers and other libraries, that is, you can't do it. You would have to rebuild the application. So it's completely different. But it doesn't, this kind of feature of, dynamic discovery and reconfiguration, it doesn't, that's why Java is heavy and it doesn't fit well into container and cloud native use cases. So, I mean, it's a loss in a bit of a flexibility, but it gives this edge of performance, Other disadvantages, well, it's relative to what? It depends on what we can compare it to. So I think in general, Quarkus is pretty versatile. You could build all sorts of applications. As I mentioned, you can develop CLIs and all sorts of compile to native. Usually it will work. I mean, that's the whole, one of the primary use cases of Quarkus was to make it easy to produce native images. So advantage of comparing Quarkus to other libraries, other frameworks, is that at build time, Quarkus has a pretty good insight into your dependencies and config. And so when we build a native image, we actually provide hints to the GraalVM compiler. So you don't have to do it manually, right? Because if you try to do this with other frameworks, usually you would have to provide a config file for the compiler to analyze. So this is where we have an edge with Quarkus. And it's, yeah, other cons, other cons would be if you have something really specific, because you have to compare it to have to be able to say this is a disadvantage compared to what exactly. So in general, I think Quarkus is a pretty cool, of course. I mean, I'm one of the developers, so I think it's a pretty good technology. But there could be, if you want to transition, if you want to migrate, for example, from one framework to another, you will most probably hit some. It depends. Some people migrate. We have good user stories that migrated in 2 days and went in production with huge saving, operational costs, and developer productivity and stuff. But you may use some features that potentially could be not easy to migrate. And from that perspective, it could be a bit of costly, but you need to try and we need to be more specific. All right. How to run tests against the application running in the native? That's a very good question. Oh, and I didn't show it. So let me explain it. Very good question. Sorry about that. So well, we have this example, but it's not a good example to copy, but here is the idea. So we have two kinds of tests. We have a Quarkus test. So the Quarkus test is more like a unit test. So the build phase in which Quarkus test is run is the test phase, right? So if we take Maven, Gradle is slightly different, but if we take Maven lifecycle, there is the relevant phases would be test, package, and then integration tests, right? So the test phase is basically unit test. So it runs before the package phase. So the application has not been built yet. The classes have been compiled, and everything is kind of ready to be packaged, but it hasn't been packaged yet. So these tests don't run they're not run against the application, right? That's what the question is about. So, but Quarkus still bootstraps an application in test mode, not from a package. It just happens in memory with all the test scope dependencies. Now, once we go through the package phase, we get the actual runnable production application. And so to test that one, we have the so-called Quarkus integration test, which runs in integration test. So if I look at the POM file, we have two plugin configurations. So there is surefire, this is the test phase, and then there is the fail-safe. So fail-safe is the integration test phase, okay? So what's cool about integration test, where is it? Here. So this one will run against an application that was built. And it doesn't matter which packaging you configured. So if you configured UberJar, FastJar, native, you build a container or something, the test framework behind it will figure it out, launch the application in the format that you built, and run these tests against the application that was launched, right? So this is the way to do it. Well, one thing is, so for simplicity, this is not a good pattern. This is just a quick way to make it work. So, well, I don't have a database running, so I will probably not launch it right now, or I could remove the entities and stuff. So basically what this does specifically in this case, it inherits the test from here. And it will just, so if I built my application in native, which I did, but I didn't run the tests, then if I actually run integration tests in Maven, this test will run and it will execute the same test and assertions against the native executable. So that's the answer, right? Any other questions? Right. Great. Well, then, I guess that will be it for today. I hope it was useful. And if you have more interest in Quarkus, then let the organizers know. Perhaps we could do something more than just the overview. All right. Good. Thanks, everyone.
Thank you, Alex, first of all, and thank you, the audience, for being with us. So we transfer to the closing session. And
there is one more question, right? So
ooh.
That's a good one as well. A breakpoint into native image. So yeah, well, so you can debug Quarkus applications in Java, in JVM mode, as you would usually do. So you can use your IDE and set it up and launch the debugger. With native image, you are in a different territory, right? And you can enable debug symbols when you build a native image, and then you would have to use the tooling that is able to debug native images. It's a bit more complicated. I think it's possible, but yeah, it's a bit more complicated. To be honest, it's also a good question. Like what are the use cases for native images? So it's definitely cool to evaluate, right, from the perspective of when you make this choice. It's not necessarily. I mean, it looks attractive, right? It's less memory. It's super fast. I mean, it's super fast, right? You could see the application, the endpoint started 11 milliseconds. I mean, what more would you like to have? But you have to evaluate the performance because JVM in the for long running processes for throughput, JVM beats native. That's for sure. With native, you get more density, but for throughput, JVM remains the choice. Great.
Yeah, thank you, audience, for all of these great questions. And we probably go to to the closing session. And we want to thank, first of all, Alex, that come to us with this great talk, and to our community partner, JetBrains. And I want to remind you to join us in our social medias, Facebook, Twitter, or X, and in Telegram. Thank you all, and see you.
Goodbye.